5G is now getting into its stride as deployments move beyond the initial enhanced mobile broadband upgrades and shift towards the core platform, the beating heart of 5G's business and services potential. But what are the attributes that make the core so critical? Well, I'm talking today with Richard Band. He is Head of Mobile Core and 5G in the Communication Technology Group at Hewlett Packard Enterprise. So, Richard, do 5G and cloud native make sense together? And if so, why?
Yeah, I believe so. Absolutely, they make sense together. I mean, cloud native is a set of technologies that has been developed to allow deployments at massive scale with lots of change and a high degree of automation. And I think those are exactly the attributes that we need in 5G. And fundamentally, 5G is about, of course, it's a new generation of connectivity, but the reason people are excited and the reason there's so much attention to 5G beyond the telecommunications industry is there's an expectation that 5G will transform other industries as well. And that means that we will have to work between the telecommunications and those other industries to adapt the network to the specific needs of those industries, to be able to be far more adaptive and reactive to changes in demand, and being able to experiment and identify what exactly is required. So much higher degree of innovation, much more agility in the way that we do things. And it's quite a difference compared to what we are used in telecommunications. I think cloud native is a critical tool for achieving that.
Okay. Now, these kind of qualities are essential at the 5G core, right? Can we say that the 5G core is by definition cloud native?
By definition, maybe not. By intent, certainly. But by definition, I would say, technically speaking, it should be possible to implement a service-based architecture with HTTP2, et cetera, using other technologies, using classical VM-based technologies, for instance. Practically speaking, though, I believe that if you look at the intent behind the service-based architecture, the flexibility to compose networks, things like network slicing that are coming beyond, at that point, cloud native becomes mandatory. Now, I do want to say a word of caution here is what we are seeing in industry is, according to me, is cloud washing to quite a certain degree. So people taking existing software and then translating that software or putting it into a container. Cloud native is more than that. Cloud native requires you to fundamentally rethink the architecture of the software, to have a strict separation of application data and call processing, to decompose the application into microservices that give you more flexibility to make smaller, more granular changes. And this is something that is a pretty substantial change in the software architecture. In fact, it's such a substantial change that we, as well as some of our partners, have decided to re-architect from scratch the software, to take a kind of clean sheet approach to make something true cloud native. What I still see in the industry is other companies taking existing software, putting it into a container and then saying cloud native. There is a difference between running on containers and being true cloud native.
Now, you mentioned automation earlier. Why is it especially emphasized in the context of the cloud native 5G core?
Right. Cloud native 5G core. So first of all, you have to look at the number of network functions that we have in 5G. Already compared to 4G, you see that the number of network functions has expanded quite substantially, and Release 16 has introduced some more. So the number of network elements is bigger than before. But on top of that, as I said before, you have to have, in cloud native, you have to have a microservice architecture, which means that the individual network functions, rather than being big monoliths, are decomposed into smaller objects. So the number of objects to be managed is a lot bigger. So volume is changing. But also the dynamicity of the network is changing. When we go into network slicing, the intent for sure is to be able to spin up a slice on demand, to move workloads around, to scale as necessary as we see that there's more demand coming, or as we see demand is changing from one area to the other. So the network is not just containing a larger number of elements, but it's also far more dynamic. And that dynamicity, together with the volume, generates a complexity that maybe in theory you can manage manually, but in practice, the cost will be prohibitive, and it's likely to lead to manual errors, which are degrading the user experience. So our belief is that you need to automate from day one in order to be successful with a cloud-native 5G approach.
Okay, well, that makes sense. How does automation actually manifest itself in the core of 5G networks?
Automation is something that happens at every stage of the life cycle. So it starts at the initial deployment. The initial deployment needs to be fully automated. And it needs to be fully automated because it gives us a base that is repeatable and we know exactly what is where. And that's the starting point. If your starting point is not replicable and is not something that you've fully documented, which is inherent to automation, it becomes very difficult to do the next steps. Now, this initial automation, here we can use tools that are coming straight from the IT world. So we have things like CI/CD for the initial deployment and the initial installation. We're using those technologies in the HP 5G core stack, for instance, to deploy a full 5G core in less than 1 hour. Now, once the initial installation is done and the initial deployment is done, additional network slices can be deployed with tools that are coming more from the telco industry, like an orchestrator, a service orchestrator for slice management. Then, once we have the slices in place, of course, as I described before, the network is expected to be highly dynamic. So you'll have to make changes. You'll have to introduce new network functions because of new use cases. You'll have to make changes in parameters. You'll have to move workloads around, etc., etc. So also this step needs to be fully automated. And every time we make a change like this, we need to inform both the fulfillment and provisioning systems, but also the monitoring system, so we know what we're monitoring. So here again, closed loop automation, the ability to tie all the pieces together is quite important. And then the last piece is, I would say, more of the lifecycle management of the software itself is, of course, we will have new versions coming out, upgrades that need to be made. And again, here, things like CI/CD are very useful. The cloud native in particular here is useful as well in the sense that microservices architecture allow us to make much more fine-grained changes in the network. So each individual network function is composed out of microservices, and those microservices have their own life cycle. That means you can make change to the individual microservice without changing other parts of the network. This allows for more frequent and more granular changes, doing away with the big forklift upgrades that we've done in the past that require complex maintenance windows, and it was a big bang approach where it was all or nothing. So getting away from that is one of the things, if not the holy grail, certainly a very important element of the automation that we're trying to achieve in 5G.
Now, there's also talk about closed loop automation as part of the 5G core and the way it works. And this involves analytics, right? Can you talk a bit about that?
Yeah, the closed loop automation is really this ability to make dynamic changes to the network in pretty much a fully autonomous manner, without a lot of human intervention or any human intervention at all. To do so, first of all, we need to gather all the information. So in a microservices architecture, each individual microservice is generating a significant amount of data, events, trace, logs, etc. What is different compared to previous generations of networks is the individual microservices themselves don't have necessarily a complete view of what's going on. By design, actually, they do not. They only see a very small portion of the world. And so the information that they're gathering is raw data. The raw data that they expose needs to be translated into useful information. So having one microservice maybe overloaded is not so relevant. Having 100 of them at the same time being overloaded, that becomes something you want to respond to. And you will only see that when you put the information together. So a first step is aggregating the data, analyzing it, and then exposing that data as useful information, being it alarms, being it KPIs, etc., etc. For this, we are using a function called the NFMF, the Network Function Management Function, and that is really collecting all the information and exposing it into a way that is meaningful for a human operator. Then the second piece of analytics that we have, or rather, once we have this information, then we can start applying analytics, and this is in two parts. One is what we call a short loop, and this is with the NWDEF, the Network Data Analytics function, which is, you can think of it as something that is actually sitting inside the network and is collecting information and has a set of predetermined pattern recognition rules, if you will, that allow it to respond directly and make changes in the network autonomously in a closed loop without human intervention. And this is a short cycle. Then the same information can be used over longer periods of time to analyze patterns or to see events that would not be relevant at this short cycle. This is what we do in the MDEF, the Management Data Analytics function. And I would say that is more outside of the network. You can consider that as part of the OSS layer. Between those two, you have the short to respond immediately, you have the long to detect patterns, maybe define new rules that go into the NWDEF, but also to give insights to the operators so they can make defined and deliberate changes into the network as a result of that analysis.
Well, I mean, it's going to be fantastic to see how all of these capabilities and how the automation will impact the services that CSPs can offer to their 5G customers. Richard, thanks very much for joining us today.
Thank you.